Good morning. I'm Dr. M. Fatima. Today I'm taking integrator using operational amplifier. The integrator circuit in which the output waveform is the integration of the input waveform. So the circuit is acting as an integrator. Such type of circuit is obtained using basic inverting amplifier configuration where a capacitor is connected in feedback. There are many applications of integrator: computers, A to D converter, linear circuits, and wave shaping circuits, and many more. This is the circuit diagram of the integrator. Vin is the input voltage given to the integrator. Ri is the resistance. IR is the current flowing through this Ri. CF is the capacitor connected in feedback. IC is the current flowing through the capacitor CF. V out is the output voltage. This is positive and this is negative. This positive terminal is grounded and negative terminal, on this negative terminal, input is provided. So input is applied to the inverting terminal of the op-amp and non-inverting terminal is grounded, as you can see here. So if the input signal is the sine wave, if it is given, then integration of the sine wave is cosine wave. So the output will be cosine from the circuit. Now see the calculation for the output voltage. Here this current IR is divided into two parts, IC and IB, but this current IB will be negligible because of presence of very high resistance or infinite resistance for an ideal operational amplifier. So this IR will be equal to IC. So I wrote here IR equal to IC. Now see the current flowing through the resistance Ri, how much it is? See, on this terminal of the Ri, Vin is present, and on this terminal of the Ri is V2 is present. So the current is Vin minus V2 divided by Ri. So here it is written. Now the current flowing through the capacitor, the charge to the capacitor is Q equal to CV. If we do the differentiation of charge dQ by dt, then that will be giving the capacitor, which is equal to IC. So IC is equal to capacitor CF multiplied by differentiation of voltage. And what is the voltage on this terminal? The V2 is present, and on this terminal of the capacitor, V out is present, output voltage is present, or V naught is present. So current flowing through the capacitor is equal to C into d by dt into V2, here V2 minus V naught. Now see the input current is equal to output current, IR equal to IC. So put the value of IR and IC here. So by putting value of IR and IC, we can see here V minus V2 divided by Ri equal to, this is equal to C into d by dt, V2 minus V0. Now we know that V1 is equal to V2, and here V1, the value of V1 is ground. So the value of V2 is also equal to 0. So put the value of V2 here equal to 0 and here also. So IR will be equal to V upon Ri, and the capacitor current IC equal to C into d by dt minus of V naught. So this term is written here, V in by Ri equal to minus of C d by dt of V naught. Now integrate this term on both the sides. After the integration of this, see here after the integration, how much we get? Just see this integration of V in divided by Ri with respect to time, and integration of this capacitor and d by dt of V naught. Integration of this, the integration and differentiation will be cancelled out. The term will become minus CF into V naught. So this term minus C V naught. We can write CF here also. So we can see here the integration of input voltage with respect to time divided by Ri is equal to minus CV naught. So output voltage is equal to minus 1 upon RIC, integration of input voltage with respect to time. So the output of the integrator is actually the integration of the input voltage with time constant, that is V naught is directly, here you can see this V naught is directly proportional to the integration of the input voltage. So that's why this circuit is acting as an integrator. Now, if the sine wave is given to the integrator, this will be providing the minus of cosine. The integration is minus of cosine. But since the output is available in negative form because of presence of inverting amplifier, so that's why the minus cos will become plus cos. So the integration of sine wave to this integrated circuit, this will be going to give the positive cosine wave. Similarly, if the unit step function is given, the unit step function is 1, and if we do the integration of 1, this will be going to give the t, and t representing the ramp signals. So this, see here, this unit step function, if it is integrated, the output will be ramp functions. Or we can say if the square wave signal is given to the integrator, the integration of square wave will be going to give the triangular wave. So this completes this lecture. Thank you.